whenever we want to separate the solid which are present in a mixture, then the separation of solids can be carried out based on the difference in size of the solid present in the mixture or difference in properties of the solid particles present in the mixture. In this session, we are going to understand about screen and screening basics. So what is screening then? Screening is a solid-solid separation technique. Now let us try to understand what is screening. When screening is carried out, how screening is carried out, the equipment used, and some terminologies and fundamentals related to screening operation. Now let us try to understand what is the meaning of screening. So it is a solid separation technique or method. It is a solid separation technique or method in which solid particles present in a mixture or sample can be separated on the basis of difference in their size using screening or porous surface. So the first question is, what is screening? It is, or screening is, a solid separation technique or method in which solid particles present in a mixture or sample can be separated on the basis of difference in their size using screen or porous surface. Now, the criteria which is specified in screening is the difference in the size of the solid present in the mixture. The equipment which is used for screening is known as screen. The equipment which is used for screening is known as screen. Now let us try to understand representation of screening operation. So the screening operation can be represented like this. So this particular diagram which I have drawn represent the screen. Say I have supplied a feed consisting of the particles of various sizes which are to be separated using screening. So this feed, whenever supplied, the particles having size smaller than the opening of the screen will pass through and are denoted as undersize. The particles, actually this particular screen is perforated, it has holes. So whenever the solid has small particle have small size smaller than the opening, they passes through known as undersize. And some solids where the size is greater than the size of the opening are retained on the surface of the screen, and these are known as oversize. That means oversize means their size is greater than the size of the opening of the screen. Undersize means the size which is smaller than the size of the opening of the screen. And therefore, whenever the feed is fed to the screen, it is separated as this oversize is denoted by T. It is separated as oversize and undersize. So feed is equal to oversize plus undersize. So in this way, if you use one screen, then you will be able to obtain two fractions, oversize and undersize. If you use two screens, you will be able to obtain three screens. So number of fractions which can be obtained by screening is equal to number of screens or screening surface plus 1. So if there are 10 screens, then plus 1 means 11 fractions can be obtained. That means the single solid sample can be separated in the particle of 11 size ranges, right? So number of fractions obtained after screening is equal to number of screens plus 1. So now let us try to understand some more fundamentals of screening. Now terminologies. Used. First, screen opening or screen aperture. So what is screen opening or screen aperture? So the answer is the clear space between the wire is known as screen opening or screen aperture. Now please remember, we may have to define or we may have to write another definition also, because it is not necessary that the screen will always be made by woven wire. Woven wire means what? See, two or more wires, threads are entangled or woven to form the opening. So now you can see, if my finger represents wire, then whenever I view them, or whenever I make the arrangement similar to the, in case of screens made by punching the hole in a metal surface. In such case, hole represent screen opening or aperture. So just imagine, say the screen can be made by two ways. The wires are woven into each other. The wires are woven into each other. So this particularly, this clear space represents screen opening. Sometimes if it is a surface, then the hole may be punched into screen. So this clear hole or clear space or this particular hole represent screen opening. So it may be made up of the woven wire, or holes may be punched in the surface, and therefore the screen, the hole represent the screen opening or screen aperture. Now let us try to understand the another terminology that is known as mesh number. Now how to define it? The number of aperture or hole per linear inch counted from center of wire counted from center of wire to another wire or simply it is defined as number of aperture per linear inch. Number of aperture per linear inch. Now let us try to understand what is the meaning of this. So So just for the sake of understanding, suppose if I start from the center of this wire and count the distance or measure the distance 1 inch, center of one wire to a distance 1 inch in a linear direction. Then how many holes are there in this particular 1 inch distance in a linear direction? 1, 2, 3, 4, and 5. Therefore, the mesh number of this wire is 5 mesh. So suppose I have started from center of wire and taken 1 inch distance. And now I am counting the hole. 1, 2, 3, 4, 5, 6, 7, 8. So the mesh number is 8. Mesh number is 8. So in this way, the number of aperture per linear inch counted from center of one wire up to counted from center of one wire to another wire in a linear direction. So suppose if the mesh number, the screen with mesh number equal to 100, the screen with mesh number is equal to 100 will have 100 holes in 1 inch. The screen with mesh number 5 will have 5 holes in 1 inch. The screen with mesh number 8 will have 8 holes in 1 inch distance. The screen with mesh number will have 100 holes in 1 inch. The screen with mesh number is equal to 200 will have 200 holes in 1 inch. So just to recap, the mesh number is defined as the number of aperture per linear inch counted from center of wire to another wire, or it is number defined as number of aperture per linear inch. So mesh number represents the number of holes in 1 inch distance in a linear direction. So if I have to write the relation between mesh number and screen opening. The relation between mesh number and screen opening. And therefore, if I have understood the definition of mesh number as number of aperture or hole per linear inch counted from center of one wire to another wire, then the relation can be screen opening. Now it's very simple to write the formula. See, if in 1 inch there are 10 holes, that means diameter of one hole will be equal to 1 by 10, 1 inch divided by 10. However, the screen is made up of the wires, and therefore you have to subtract the wire diameter from that, and therefore screen opening is equal to 1 upon mesh number. Now 1 upon mesh number gives the diameter of one hole, but whenever I do 1 upon mesh number, it includes wire also, and therefore I have to subtract wire diameter. Now for the sake of your understanding, I will draw some enlarged figure. So imagine this is just the one hole. Now whenever I'm interested in finding out screen opening or screen aperture size, what do? I take the inverse of mesh number. That is, if mesh number is 200, then screen opening is equal to 1 upon 200. If the mesh number is 100, then screen opening is equal to 1 upon 100. But that is not correct. Why? Because the screen aperture or screen opening is the clear space between the wire. It is the clear space between the wire. So whenever I do 1 upon mesh number, I don't get clear space. So what I should do now, if I consider this hole, then starting from center of this wire to center of this wire, center of one wire to center of another wire. Now center of one wire means one radius of wire, and center of another wire, that means radius of that another wire. So radius plus radius is equal to diameter, that means one wire diameter, right? And therefore screen opening is equal to 1 upon mesh number minus wire diameter. So say if the mesh number is 200, then what will be the screen opening? Screen opening will be equal to 1 upon 200 minus diameter of wire or wire diameter. Then you will get the clear space. What is screen opening? Screen opening is the clear space between the wires. It is clear space between the wires. So this particularly red portion represent the clear space. But when I take the inverse of mesh number 1 upon mesh number, it also include the wire also. So half the, if I start counting from center of one wire to the and end at the center of another wire, then I have to consider two radius, that means one wire diameter. So screen opening is equal to 1 upon mesh number minus wire diameter. So from this discussion, what you will understand is, as mesh number increases, the screen opening or aperture size decreases. So if I consider 10 mesh screen, and if I consider 200 mesh screen, so for 10 mesh screen, it will be 1 upon 10 minus wire diameter. For 200 mesh screen, it will be 1 upon 200 minus wire diameter. So in this case, obviously, as the term which is there in the denominator increases, the product of this division decreases, and accordingly screen opening decreases. So higher mesh number means the smaller screen opening, and lower mesh number means larger screen opening. Now the third term is ideal screen. Now what is ideal screen? The screen which separates undersides and oversize material perfectly. The screen which separates undersize and oversize material perfectly. Or the screen for which perfect separation, or using which perfect separation is obtained, is ideal screen. So ideal screen is the screen which separates undersize and oversize material perfectly. Ideal screen is the screen which separates undersize and oversize perfectly. The screen for which perfect separation is obtained is ideal screen. It means there is no overlap of 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 undersize and oversize. It means there is no overlap of undersize and oversize. What does it mean? Let us try to understand again. So suppose if I consider the screen, if I supply the feed, it is separated into oversize and undersize. Now, the flow of the undersize material is known as underflow. The flow of oversize material is known as overflow. That means the oversize material should be present in overflow. Overflow means the flow of the material which is retained above the screen. Underflow means the flow of the material which passes through the screen, right? Overflow means the flow of the material out of screening equipment which is retained on the screen. Underflow means the flow of the material out of screening equipment which passes through screen. Now, if anything passes through the screen, that means size of that particular material must be smaller than the size of the opening. Then only it will pass through, right? So it means there is no overlap of oversize and undersize. The another meaning is all oversize material is it means all oversize material is present in overflow. The another statement is all undersize material, all undersize material is present in underflow. So if all oversize material is present in overflow, if all oversize material is present in overflow, all undersize material is present in underflow, it means there is no overlap of oversize and undersize. That means there is no undersize material present in overflow or no oversize material present in underflow. So the screen which separates undersize and oversize material perfectly, the screen for which perfect separation is obtained is ideal screen. It means there is no overlap of undersize and oversize. It also means that all oversize material is present in overflow, all undersize material is present in underflow. A fourth term which may be often discussed is real screen. Real screen means what? If you understood ideal screen, you will be able to define what is real screen. Real screen means the screen which does not separate oversize and undersize material perfectly, or the screen which does not yield perfect separation of oversize and undersize. Or third definition is the screen in which after screening we obtained two fractions with overlap of oversize and undersize. What does it mean? Some undersize material is present in overflow and some oversize material is present in underflow. So the screen which does not separate oversize and undersize material perfectly is known as real screen, or the screen which does not yield perfect separation of oversize and undersize is real screen, or the screen in which after screening we obtain two fractions with overlap of oversize and undersize. That means oversize material is present in underflow and undersize material is present in overflow. Now, what is overflow? Overflow is the flow of the material out of the screening equipment which is retained over the screening surface. What is underflow? It is the flow of the material outside screening equipment which passes through the screen. So real screen means the screen which does not yield the perfect separation of oversize and undersize. And what is ideal screen then? The screen which yield perfect separation of oversize and undersize. So in case of ideal separation, there is no overlap of oversize and undersize. Means all oversize material is present in overflow, all undersize material is present in underflow. However, in a real life, we doesn't observe the performance similar to ideal screen. There is always overlap. Therefore, some undersized material is present in overflow, some oversized material is present in underflow. And as the real screen does not yield the perfect separation, efficiency of the real screen will be less than 100%. Whereas, as the ideal screen yields the perfect separation, the efficiency of the ideal screen will always be 100%. Cut diameter. Now, what is cut diameter? It is the diameter of diameter of particle or a diameter term, say, which is just smaller than smallest particle in overflow and just larger than largest particle in underflow. So it is the size of the material or a diameter term which is just smaller than smallest particle in overflow and just larger than largest particle in the underflow. So in simple language, cut diameter is ideally equal to size of screen aperture or screen opening. So cut diameter ideally is equal to screen opening or screen aperture size, right? So in this case, I can say that generally in case of the real screen, some undersized material is present in overflow. some oversized material is present in underflow. So in that case, it is possible that some oversized material may be present in undersize, some undersized material may be present in oversize. So there is overlap of oversize and undersize. So in that case, this cut diameter has no meaning, because it is possible that even this underflow may consist of the particle size greater than the smallest particle size in overflow, or overflow may consist of a particle having size smaller than the largest particle in underflow. So this cut diameter is the imaginary concept or the ideal concept which represent the perfect separation. So if perfect separation is obtained, then and then only this term will have any meaning. So it says that the diameter of a particle or a diameter term which is just smaller than the smallest particle in overflow and just larger than largest particle in underflow, right? So in simple language, cut diameter is equal to screen opening. If I have to represent the cut diameter using certain diagram, so if I plot the screen analysis, then if this is equal to DPC, so say DPC means cut diameter may be represented as DPC. So say this is oversize and this is undersize. Obviously the oversize will always have the overflow. Say this is overflow and say this represents underflow. So this overflow will always consist of oversized material. The underflow will always consist of underflow material ideally, and therefore these particular fractions represent oversized material. This particular fraction represent undersized material. So what does it mean? All oversize is present in overflow, all undersize is present in underflow, and therefore the diameter which is just larger than largest particle in underflow means this, and just smaller than smallest particle in overflow means again this. So this cut diameter ideally represent screen opening. This cut diameter is nothing but the opening of the screen aperture size. So that's all for today's session, where I have tried to cover the basic terminology related to screening operations. In subsequent sessions, we'll try to learn some more fundamentals about the screening operations. Thank you very much for listening to video and trying to understand the fundamentals of screening operation. Thank you once again.